This video is on the fundamental theorem of calculus part 2. So hopefully you watched the fundamental theorem of calculus part 1, and now you can get a hold of part 2. So basically what we're doing is we're looking at this second part of the fundamental theorem of calculus, which says if f is continuous at every point on the interval a to b, and capital F is any antiderivative of f, then the integral from a to b, which we will call the definite integral, because we have two numbers in there, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. Typically, we do not include, basically what we do with this any antiderivative thing is we do one that doesn't have a constant. And the reason why is the constant ends up out in the wash anyway. So, for example, let's say I have the integral from 2 to 4 of x dx. I know that an antiderivative of this is 1/2 x squared plus c. Okay, so the notation that we'll use for evaluating an integral at points is we're going to put this line here and we're going to say it goes from 2 to 4. So then we will evaluate it by subbing in 4 into this and subbing in 2. So if I sub in 4 for x, what I end up with is 1/2 4 squared plus c, and then I subtract 1/2 2 squared plus c. Now what you'll notice is that the c's are going to cancel out, and that's going to happen all the time because we have plus c and then minus a plus c. So those are going to cancel out. We don't really need those c's, and that's why whenever we take antiderivatives in definite integrals, we're not going to really use the c. We only use the c when we have an indefinite integral. So in this particular problem that I just made up, I have 16 divided by 2, which is 8, minus 4 divided by 2, which is 2. So this answer is 6. So now let's do the fundamental theorem of calculus part 2 in about 6 different examples. Example number 1, the integral from negative pi to pi of cosine x dx. I know that an antiderivative of cosine x is sine x. I don't need the plus c because I'm doing the fundamental theorem with definite integrals. So I'm going to evaluate that from negative pi to pi. So I'm going to say sine of pi minus sine of negative pi. And I know that sine of pi is 0. I know that sine of negative pi is also 0. So 0 minus 0 is 0. Number 2, the integral from 1 to 5 of x squared minus 3x plus 4 dx. So if I evaluate this, I take an antiderivative, which is 1/3 x cubed minus 3/2 x squared plus 4x. I take this and I evaluate it from 1 to 5. Sorry. So I'm going to evaluate this from 1 to 5. So I substitute 5 in. I get 125 over 3 minus 75 over 2 plus 20. And then I'm going to subtract 1/3 minus 3/2 plus 4. And so then I get 64 thirds. Number 3, the integral from -3 to -1 of 2x squared minus 5. That is, if we take an antiderivative of this, we get 2/3 x cubed minus 5x. And we're going to evaluate that from -3 to -1. So if I sub in -1 here, I get -2/3 plus 5. And then I'm going to subtract what happens when I sub in -3. So that gives me -18 plus 15. So when I simplify that, I get 22 thirds. Number 4, the integral from 0 to 1 of 1 over 1 minus x, or the square root of 1 minus x squared dx. We have to recognize that the thing that gives us 1 over the square root of 1 minus x squared as a derivative would be arcsine or sine inverse. And so we have to recognize that sine inverse is the antiderivative of this. We evaluate that from 0 to 1. So we have sine inverse of 1 minus sine inverse of 0. Sine inverse of 1 is pi over 2. Sine inverse of 0 is 0. We can get that because we figure out that pi over 2 gives me 1 when I plug pi over 2 in for sine. And sine of 0 gives me 0. So that's why that works. So my answer is pi over 2. Number 5, the integral from 1 to 2 of 1 over x squared plus 1. The thing that I should recognize out of this is this comes from tangent inverse. So if I take the derivative of tangent inverse, I get 1 over x squared plus 1. So that means that the antiderivative of 1 over x squared plus 1 is tangent inverse of x. I'm going to evaluate this from 1 to 2. So I get tangent inverse of 2, which we don't know the answer to, minus, or we don't know how to simplify that, minus tangent inverse of 1. We do know that tangent inverse of 1 is pi over 4. So we can say tangent inverse of 2 minus pi over 4 is the answer to number 5. And finally, number 6, the integral from 1 to 3 of 2e to the x dx. 2 is a constant, so I can move that to the outside. That's one of the integral rules. The integral of e to the x dx is going to be e to the x dx because the derivative of e to the x is e to the x. So the integral of e to the x is also e to the x. So I end up with 2 times e to the x, and we're going to evaluate that from 1 to 3. So I have 2e cubed minus 2e. And if I want to, I can factor out a 2e, and I get e squared minus 1, but that's not necessary all the time. And that is the fundamental theorem of calculus, part 2.